All right, great. I guess we can get started. And thank you everyone for waiting. Welcome and thank you for joining us for today's webinar. My name is Jenny Gao. I am the Assistant Director of Research at C2 Smarter, a USDOT Tier 1 University Transportation Research Center. Today, we're joined by Professor Morteza Bagheri, an Associate Professor from Iran University of Science and Technology, who will present how to mitigate risk in rail transport of HAZMAT. Professor Bagheri is an associate professor jointly appointed in the School of Railway Engineering and the School of Industrial Engineering at Iran University of Science and Technology. He has a PhD in Transportation Engineering from the University of Waterloo, a Master of Science in Management of Logistics and Transportation from Chalmers University of Technology, and postdoctoral research in Management Science at McGill University. Professor Bagheri also serves as the Director of Transportation System and Logistics Research Lab. As always, we'll be recording this webinar and uploading it to C2 Smarter's YouTube channel. We encourage everyone to ask questions. You can press the Q&A button at the bottom of the Zoom window, and I will read out your question at the end of the presentation. And with that, I will hand things over to our presenter to get us started.
Good morning, everyone. Can you hear me? Okay, shall we start? My name is Morteza Bagheri. Thank you for Jenny for introduction. Today's presentation is about how to mitigate risks in rail transport of hazmat. So, currently I'm a visiting professor in transportation planning group at ETH Zurich. About my background in industry, I have been involved in many rail projects in RAI Company, National Railway Company, and Port and Maritime Organization, and also road organization. Also, I'm a founder of 3 startup innovation centers called HADAF and Borna, and I'm a co-founder of Avan Barzin, a knowledge-based company in the back home looking at the health monitoring of rail infrastructure. And also I'm a director of Transportation System and Logistic Research Lab since 10 years ago. In terms of the 3 selected publication published by Springer, Sustainable Rail Transport of Dangerous Goods, and Current Trends in Reliability, Availability, and Safety. In terms of the administration, I act as an advisor and a special assistant to the Minister of Roads and Urban Development for 8 years. And also I act as a Chancellor of International Campuses for 3 years at Iran University of Science and Technology. In terms of the international experiences, I lived in many different countries and traveled to 28, from Africa to Europe to Canada. I'm a faculty member at the School of Railway Engineering at Iran University of Science and Technology. The school is one of the top 3 technology university, and we are celebrating soon 100 years old, and a pretty big campus, 42 actors, and we have 15 schools and more than 450 faculty members and more than 15,000 students. And something unique about this university is a School of Railway Engineering. So this school is established in 1997, and we have around 30 faculty members and 3 majors in undergrad program, industrial, mechanical, and civil. And in graduate study program, it's also electrical and safety added to those 3 undergrad program. Again, my research lab is now 20 members. We have 20 members, 1 postdoc, 5 PhD, and the rest are master student. You can follow up on LinkedIn. We are very active. Here in ETH Zurich, I'm a visiting professor in Institute for Transport Planning and System. To be familiar with this institute, they have three different chairs, and one is Transportation Systems Group by Professor Francesco Corman, and also another group is Transportation and Mobility Planning and Traffic Engineering. So basically three different group and chairs together, get together to institute. For today, I would like to give you some introduction and then some examples, literature review, and conclusion. If I can share a video here, that would be great. So you can see. Let me see if I can share you a video that I prepared. It's just to make sure that you are seeing this video. Can you, yes, can you see this, Jenny?
Yep, you can see the page and video. Possibly the audio will not come out, but I guess we can still see what happened over there. Oh, well, actually the audio is out.
Astonishing breach. Hazardous materials turned up in the air and the soil across 16 states and in Canada. 110 million people were impacted by the pollution, far more than first believed. However, the chemicals have not been spotted anywhere in our area. The study claimed.
So, yeah, it's a little bit internet connection, sorry. But you see
Claims the detected chemical concentrations, which included vinyl chloride.
So this is a recent derailment in the US. HAZMAT train derailed, and it affected 16 states. So now you can see my slides.
Yep.
Okay, more than 38 cars derailed and 11 ignited, and the fires for 2 years spread hazmat pollution to 16 states, US states, and evacuation of 2,000 residents with 1 mile radius. So this is the NS train derailment back in February 2023. And after that, in March, again, another train derailed, 23 mixed freight rail car, 14 hazmat, 10 containing ethanol, and again, evacuation of 800 residents, around $2 million US damage to railroad equipment and track. Back in 2013 in Canada, there was a hazmat train derailment, 47 cars of crude oil derailed and exploded, 42 people fatality, and $7 million Canadian dollar for damage, including the cleanup cost. Back in my country in 2004, there was a huge accident called catastrophic accident, 289 fatality, and 5 villages were seriously damaged. And there was a big crater with 27-meter depth and 8-meter width, and the earthquake registered 3.6 point in Richter scale. So these are motivation why we are looking at the derailment. So train derailment is one of the 3 main rail accidents by type. Looking at the statistics in North America shows that more than 50% of the accidents are train derailments, and train derailments itself has consequences and damages per wagon like $100,000, but when it includes the dangerous goods or hazardous material, the consequences 5 times more in terms of the property damage. But the major threats are personal injury and long-term environmental damages. So what are the different ways to reduce and mitigate the risk? Of course, one of the simple solution is to reduce the risk of train derailments by improving track infrastructure, but adding more work zone in the network means a lot of delay, because you need to block the segment for a train. And also itself, the safety of work zone is an issue. 2 years ago, there was a work zone in one of the rail segment in my country, and the train collided with excavator, the basic maintenance and repair machines, and 14 fatalities and 86 injuries. Another way is to prevent involvement of hazmat car in accident. I will come back to this later. Basically, we're trying to put the hazmat cars in a position which has less likelihood to be derailed, calling in-transit risk. So we are trying to mitigate the in-transit risk, but to put the hazmat cars in the position which has less likelihood to be derailed, we need more additional work at the rail yard. So by mitigating the in-transit risk, basically we are increasing the railroad risk. So it is important to have a trade-off and optimization, because as we changing the position, for this example in the rail yard, changing the position of the wagon X with wagon Y, when we have only one empty track, we are adding more marshalling and buffering of the cars, which means more additional work and more risk for the rail operators working in the rail yard. That's why in the paper in Transportation Research Record, Morteza work on the this trade-off, and we publish a paper to have a comprehensive risk model minimizing the hazmat train derailment, not only in transit, but also for the rail yard risk. I will not go to the details of the formula, but calculating the population and consequences could be very complicated. Another way is to looking at the likelihood of release of hazmat. So if the train derailed, if the hazmat car involved in an accident, how we can decrease the risk by reducing the risk of release of hazmat. One way is to change the design of the cars, and there are many studies done in Illinois, University of Illinois at Urbana-Champaign by Professor Christopher Barkan and his team. But again, it's a trade-off, because if changing and designing the cars means more weight, that means that we, instead of one big train, we need to have 3 or 4 trains. So for one train, although we are reducing the risk of release, but when we have 3 travel, then we have 3 more chances to be derailed. Again, it means a trade-off. It means we need a trade-off and optimization here. And finally, last but not least, in the rail network, like a US rail network, which is very complicated, there are many options one way to reduce the risk is that if the train derailed, if hazmat cars involved, and even if the cars released, we reroute the hazmat train to the segments which has less populated and with less vulnerable points. So the consequence can affect the less number of people. But again, if we choose that route for all the trains or most of the trains, then the equity concern come to the place, basically saying that those people are more prone to exposed to the hazmat cars. So I reviewed these four approaches to mitigate the risk. Now I want to show you just a small example, considering my time, for the prevention of hazmat involvement car in accident. So this is very simple study framework. So we are for calculating the probability of the derailment, we need to know two type of attributes. One is route attribute, and the second one is the rolling stock characteristics. Based on that, we can calculate the probability of the derailment for each slot and putting the hazmat cars to those slots which has less likelihood. And this is the different modules that we need to calculate. So based on the rolling stock attribute and route characteristic, we will end up with the risk by position. And how we calculate the risk by position is that we can find the distribution of the cause of derailments, and then based on that, we can calculate the point of the derailments and number of cars derailing, and also the probability of the train derailment. There are some regulation in terms of the putting the hazmat cars in the train in the US and in Canada, for example. It says that it can, for example, you cannot put the hazmat cars near to the engine. So there should be enough buffering between the engine of train and the hazmat cars. Also in Canada, this is the example for in Canada for CP train, that you cannot put incompatible hazmat cars together. So this gives us the some regulation that when we want to put the hazmat cars, we should consider the regulation. Again, when we are looking at additional operation in the classification process, that means that if we want to change the position of the cars when we have one empty track, and look at this, we should take out one part going to the empty track. Again, we should go back, and now the Y come to the X position. So this way we change. So this is needs 4 turnout operation, and that means a lot of work just to changing the wagon Y to put it in the position I. So for a real case study, we'll look at the Barstow going through to Chicago, passing Albuquerque and Kansas City. That's the real corridor, but in terms of the segmentation, we basically hypothetically think that from Barstow Yard, we have 2 segments to Albuquerque, and then from Albuquerque to Kansas, we have 3 segments, and then 1 segment to the rest. And you can see the distance, the track class is speed, and based on that, we calculate the probability of train derailments. And then looking at the segmentation, we can find the distribution for causes of the derailment based on the historical data. And also the distance from rail yard number of cars, number of dangerous goods. So usually based on the historical data, we can think in the mixed train, we have 10% of the freight cars as a hazmat or dangerous goods cars. And we can have different marshalling strategies. One strategy is putting the blocks based on the destination, saying that, for example, the Albuquerque comes first, the block, then the Kansas block come after that, and finally the Chicago. So CKA basically saying that the Albuquerque blocks comes after engine based on and the position of the cars here is the random position considering do nothing strategy. But for CK star, we keep the order of the blocks, but we put the hazmat cars in the position which has minimum risk based on the risk of each position. And the rest strategy, you can see at the bottom, the 5 different strategy based on changing the order of the blocks, which means additional work in the station when they comes, because we need to marshalling and buffering, but we didn't look at that at this point. We just consider simply we can change this. So as you can see, the different risk and time for different strategies can be calculated. And also here, again, the percentage change in the corridor based on the time and also the risk. But we look at the literature review too. In the literature review, they have some strategies saying simply that putting the dangerous goods at the end. Some of them propose putting the dangerous goods on the front, and some of them, and the third one is putting the dangerous goods in the position which has minimum risk, not considering the real constraint in the regulation. So again, the CKA3, not considering the regulation, gives us the better value, but in real world, we cannot do that. The CKA star gives us the minimum risk, and do nothing gives us the very high risk. But yeah, this is random positioning. And CKA2 gives us the very high risk values. Again, CKI2 is putting the dangerous good on the front. So basically, it's not a good, maybe it's not a good strategy to follow the putting the dangerous good on the front, because it gives us more risk value. So major finding for today presentation, I showed you 4 different approaches to mitigate the risk of hazmat cars, and also I gave you one example for the one real case study in Canada, in the US, and this work is still in progress because we need the comprehensive risk model, which gives us not only the rail yard in transit risk, but also the rail yard risk too. So at the end, I would like to thank Professor Khan Ozbay, the head and director of C2 Smart Laboratory, and my host here in ETH Zurich, the Risk Center and Institute for Transport Planning and System. And also at the end, I would like to thank Jenny and Elizabeth and all group here who are very kind and their hospitality in the Zurich. Thank you for your attention, and I would like to have your question or comments.
Thank you, Professor Bagheri. And that's just as a reminder, we invite all questions So please enter yours by pressing the Q&A button at the bottom of the Zoom window. And I guess while we're waiting for questions to come in, Professor Bagheri, I'm just curious. This is a totally new area to me, so very informative to learn, some things about the HAZMAT. But just curious because there are so many like ITS innovations recently, right? Like computer vision technology for detections, other stuff, and I'm just wondering like how can these emerging technology be leveraged maybe in this field to improve the safety of HAZMAT transit? And also, do you know, like maybe you can give us a little bit more about if there's any recent innovations or considerations more towards like intelligent, transporting systems?
That's a very good question. When we are thinking about the ITS in road and for the automobile, we can think about the reaction of the driver. But in terms of the train, even if the driver see the obstacle and even he or she break the train, depends on the train speed, it needs 1 kilometer to stop the train. So you cannot count on the train drivers in terms of the accident or the derailments. The another reason is that for rail industry is still following the traditional old lifestyle in all over the world is one of the technology that's following very far from air industry still, and there are many potential to work ITS in the rail. For example, one example is that the train drivers, when one car derailed from 200 cars, he didn't get the alarm that one car derailed. Still, he continue his operation, and after 10-20 cars derailed, he understand that something happened. So one of the ITS application can be to inform the train drivers as soon as one car or even one wheel derailed from the track. These are different approaches. And the final one is you can think about the ITS for the human factor. There are many applications now for train drivers looking at the distraction of the train drivers, cognitive function of the train drivers, which can prevent the accident. In fact, in my research lab, since 8 years ago, we conducted 10 different studies looking at the human factors for the people who work in rail, from train drivers to shunters. For instance, putting the camera in the train driver cabin to see the fatigue of the train drivers, because the train drivers, sometimes they have to look at the two track for 8 hours, 6 hours, and unintentionally they become fatigued, and they cannot control when they should control. So there are many potential for ITS in the rail again, and my research lab and I would be happy to collaborate if somebody is interested in.
Awesome. It's very excited to hear that there's so many different ITS has been kind of like considered in this field, and hopefully we'll see more in the future. So there's one more question about, because you've been to so many different countries, and of course every country has different regulations, requirements of how to operate the trains. Have you seen any like international examples of successful HAZMAT risk mitigation strategies that might be able to adopt it in the US, or maybe just, difference between what you see from different countries?
I selected the example from the US because I'm presenting today for New York University. It doesn't, even the motivation examples I intentionally selected from the US to motivate students who are watching us today to start thinking about this issue and working on this issue. But it doesn't mean that the US rail operation is not safe or they are really concerned. In fact, if I would like to give one of the good example of safety of HAZMAT, I would say the US operation is pretty good and can be a good example of for benchmarking. The reason that you hear a lot about the train derailments involving HAZMAT, 1 week ago, there was a conference called BTR, Bridging Transport. It's a famous online conference. My student presented a paper about hazmats by train, and professor raised a hand and said, why we are hearing many accidents here in the US carrying hazmat? The answer is because the exposure and frequency of the train operation carrying hazmat is pretty high in the US. And in fact, I would say more than 90% of the trains carrying hazmat arriving their destination without any problem. But you never receive any news about the successful operation. We usually receive news about the accidents. So these accidents really doesn't show that the operation is pretty bad, but still we can work on that because they consider as a rare event and low likelihood, high probability accident. So yes, that would be my answer to this question.
Thank you. I don't think I see more questions coming from the Q&A, so I would say thank you everyone for joining today, and especially to our presenter, for this such informative webinar. A recording of this webinar will be available on the center's YouTube channel and website later on. Thank you again, and hope everyone have a great weekend.
Thank you for your attention.